The objective of this video is to calculate the nutrient requirements for a wheat crop in North Carolina. This includes lime, phosphorus, and potassium. To go through this process, the first step that we need to do is to calculate the amount of lime that are required for our 20-acre field. To do this, we use the equation that you were given in the notes using active acidity, target pH, and the current pH. Our total lime that we need in tons per acre equals target pH minus field pH divided by 6.6 minus field pH times active acidity. In this case, we have our target pH of 6 minus our field pH of 4.8 divided by 6.6 minus our field pH of 4.8 times our AC, which is given as 2.6. This equals 1.2 divided by 1.8 times 2.6, which is equal to 1.73 tons of lime. We can calculate the total amount of lime needed once we have the number of lime required. So we have 1.73 tons of lime that are required per acre times 20 acres. So the total amount of lime that we need is 34.6 tons of lime. The next thing we're required to do is calculate how much lime is required using the CCE ratio. Because we are not using calcium carbonate, we're using wood ash that is only 72% as effective as calcium carbonate. We need to add more lime than this 34.6 tons of lime. We have 34.6 tons of lime. For every 100 tons of this wood ash is equal to 72 tons of lime. 48.1 tons of wood ash is calculating the total cost of liming. And that involves taking the 48.1 tons of wood ash and multiplying that by the total cost for delivery. So to buy and deliver our lime, it's going to cost us $40. So that equals a total of $1,924 required for lime. Our next step involves calculating the total amount of phosphorus that we're actually going to need. So, in order to do this, we use small grade equation number 15 in the North Carolina recommendations for phosphorus. Equation 15 is 0.0140. This I value right here is our phosphorus index, which is located up here, which is 22. And so is this I value here. So our total equation is 22 squared times 0.014 minus 3.2 times 22 plus 150 equals our pounds of phosphorus per acre. This value calculates out to being 6.78 minus 70.4 plus 150, which equals a total of 86.4 pounds of phosphorus for every acre. Our next step after we get pounds per acre is to actually calculate the total amount of pounds. To calculate our total fertilizer required, we just take that 86.4 pounds that we calculated per acre, multiply that by 20 acres, and we know we need a total of 1,728 pounds of phosphorus. So once we know our pounds that we have per our 20 acres, our pounds per 20 acres, our fertilizer, our P fertilizer is 46%. Tell up here that it's 46% phosphorus. So we take 1728 pounds of P2O5 times 100 pounds of 0.460, then divide that by the 46 pounds of P2O5 in the 0.460, and then we convert this to tons. So 1 ton is 2,000 pounds of the 0.460. So we have the P2O5 cancels out, and now we know that we need 1.9 tons of P. Then we can calculate the total cost with 1.9 times the $250 per ton that we have listed up here. And we end up with a total of $475 for P. Now we need to repeat the entire process over for potassium. In wheat, we use calculating equation number 14 instead of 15 for our K recommendations. That is 0.116 times I squared, and in this case, our I is 28. Minus 2.75 times 28 plus 150 is our pounds of K2O per acre. And this one boils down to 9.09 minus 77 plus 150 equals 82 pounds of K2O per acre. We can calculate, now that we know that, we can calculate the total amount of fertilizer required. So in this case, we had 82 times 20, so 82 pounds per acre times 20 acres is 1,642 pounds of K2O required. Converting this to tons, as well as knowing that we have 60% of K2O in our fertilizer. So we have, for every 100 pounds of 0.060, we have 60 pounds of K2O. So that gives us our pounds of fertilizer. To convert to tons, we use 2,000 pounds of 0.060 is 1 ton. And that gives us a total of 1.37 tons of fertilizer needed. Then we can calculate the total cost. So we have 1.37 tons of K fertilizer, and we know that it costs $300 per ton. And that gives us a total cost of $410. So the final thing that we need to do is to calculate our total fertility cost. So we learned that we had $1,924 required for liming, $475 required for phosphorus, and $410 required for potassium. So then we can sum all of these together. So that's 9, 10, 18, 2. So we need a total of $2,809 to fully fertilize our wheat crop on 20 acres.